Hello everyone, Zero Fossil Fuel. Today is Saturday, May 30th, 2013, and this is your Zero News update on the generator dynamo project. I'm going to entitle this video "Shooting for Lenz," and I think we may have some progress. And what I am holding in my hand may be the key to defeating the Lenz effect. I saw an interesting video on YouTube about a gentleman who was doing some experiments with plasma in the presence of magnetic fields created by bowl-shaped magnets in a vacuum, also purged with argon and neon and hydrogen and all kinds of other gases to try his experiments. And it gave me an idea for winding a coil that produced a similar magnetic pattern as his permanent magnets that he was experimenting with. The video link will be down below in the comments section if you want to view that video. It's quite long. It's a 3-part series. Each part is about 1 hour long, worth watching. But what I ended up doing to create this electromagnetic coil that resembles his permanent magnets was I stole this little globe from my wife in the bathroom. It is just a little stone type globe that covers her little tiki candle burner in the bathroom. It has a hole open in the center of it. And as I looked at this, I said, this looks an awful lot like the antenna array that Nikola Tesla was building at Wardenclyffe. And when I finished winding my coil, which I used this tiki candle cover as a coil form. All right, you can see in this picture here how I've done that. As I finished this coil and took it apart and looked at it and said, this looks even more like the antenna array at Wardenclyffe. And P.S. also resembles some of the HARP antenna arrays that you may have seen along the highways. So what you're about to see are the results of my findings comparing this coil with the standard Tesla pancake coil. And I'm comparing this both to a bifiller Tesla pancake coil as well as a quad filler Tesla pancake coil. And the results are actually quite dramatic. So let's move right into the experiment. Before I do this, I want to show you, want to mention that along with the Muller wheel that has the 8 magnets in the wheel, I also created this spinning drum on a hard drive bearing. It is driven by my quad filler pancake coil. And with 11 volts going in at about 2 amps, I have this spinning at about 10,000 RPM. Inside this drum are 4 N52 neodymium bar magnets. They are 1/4 inch thick, 1 inch wide, 2 inches long. They are standing on end. They are all opposing one another, so I have the same pole facing outward in all directions. It is very precisely balanced, and it makes an excellent platform for testing different coil arrangements. And I wanted to as closely replicate what Sky Collection had done as I could with his rotating drum, because not only do the magnets move past the coils, they also move inward towards the coils and away from the coil as it's passing the coil. And I felt that might also possibly be quite significant in the process. But I will be testing these coils also with the Muller wheel to see what the effects are. So let's get right into it. All right, so here's the test apparatus. I have my 4-layer pancake coil right here. Each layer of the pancake is wired in series with the next adjacent, and the 4 series connected pancake coils are driven by these 2 wires into this Alco switch, which switches the coil between the driver circuit when I'm accelerating the wheel and between a load on the outside when I want to decelerate. You'll see I have a set of 4 diodes to give me some DC if I want to try DC. All right. But the first experiment I'm going to show you is I'm going to accelerate the wheel up to approximately 7,000 RPM. I'm going to adjust my voltage on the power supply to 7 volts. I'm going to accelerate the wheel to about 7,000 RPM, and then I'm going to flip the switch and put a dead short across the coil that is actually driving the wheel before I flip the switch. Okay? And you get some idea of the deceleration curve. I'll probably end up putting a stopwatch on this later and leaving the actual figures in the comment section once I review this video and finish producing it. But here we go. I'm going to see. Yeah, you should be able to see the speed. It is kind of difficult to get this thing focused right. There we go. 6,500 RPM. 67. 6850. I have to change the angle here. I think the sunlight coming in is affecting. Maybe I need to get closer. Yeah, that's what it is. I need to get closer. All right. 7,030 RPM. All right. Decelerating in 3, 2, 1, mark. Stop. I'm going to call that a full decel right there. Okay. Now, when this coil, when this wheel is spinning, the voltage induced in this 4-layer coil is approximately 15 volts peak to peak, or 7 volts peak, 7.5 volts peak, or roughly 4.5 to 5 volts RMS. The difference now here is a 16-turn bifiller pancake coil. I'm going to attach my oscilloscope to it, and I'm going to bring it into the wheel and measure the peak-to-peak voltage. Once it has come up to full speed. $69.50, $69.80, 7,000. Incidentally, it only draws about 1.1 amps, so just a little over 7 watts input. All right, there's 7,045 RPM. And with this coil, I'm able to generate just under 3 volts peak to peak. And here's that 3 volts peak to peak on the oscilloscope. Okay. Now I'm going to apply a short circuit to this coil. And place it in the presence of the moving magnetic field. And you will be able to get an idea of what the deceleration profile is for this coil. Three, two, one, go. And stop. All right, so that's for a coil that produces only 3 volts peak to peak with the dead short across it and the Lenz effect that's created by this coil in the presence of the moving magnetic fields. Here's what I'm calling the Wardenclyffe coil. Okay, again, here's a close-up of how this is wound. It is a half bowl-shaped, and essentially what it does is it creates a monopolar magnetic field. One pole is on the inside of the bowl, collapsing on itself. The other pole is on the outside of the bowl, emanating outward. So the inner pole is self-shielded, if you will, because it's being compressed in upon itself. Kind of makes me wonder what would happen if you took one of these and made a full globe out of it. Maybe later. So anyway, now I'm going to take this magnetic wheel, bring it back up to full speed, measure the no load voltage output, of this coil. Unfortunately, I'm unable to do split screen right now. I'm not using Webcam Max. I have to film these voltage readings separately. I know that's going to create skepticism, but that's the best I can do right now. And at quite a distance, I'm already picking up voltage on the oscilloscope, but I'm not going to bring it in just yet. So I'm at 7,020 RPM, so we're up to speed. And with this coil, I'm able to get, at 7,000 RPM, I'm on 1 volt per division, and I'm deflecting 5 full divisions, so I've got about 5 volts peak to peak. Correction, 6 volts peak to peak. So I'm producing twice the output voltage, twice the potential power. Now I'm going to place the short circuit on this coil. And we'll do the same deceleration measurement. Again, I will have to put a stopwatch on this after I complete recording this video. But I already know it takes longer, and here's the proof. All right. So short-circuited. 3, 2, 1. And stop. All right. Next, I'm going to do those same tests, and I can show you this in real time. With the wheel energized and spinning under power, and measure the difference in the loading effect of the coils when the wheel is up to speed. Now we know this is going to come up to 7,030 something RPM. We're already up to 6,850, 6,870, 6,900. There's 7,000. All right. Now, here's the 3-volt single layer coil. I'm not touching the wheel, I'm only in the presence of the magnetic field. You can hear it slowing down. And as I witnessed before, I'm down to under 4,800 RPM. I'm at 4707. All right, so I went down from 7,030 to 4707 RPM with a short-circuited coil in the presence of that field. Now I'll do the same thing with the Wardenclyffe coil. This is short-circuited. We've got 7,000 RPM. And we are getting some. And this is as close as I can get without dragging the wheel. But on a coil that can produce twice as much power, I have only slowed to 5,985 RPM. (5,985 RPM). And I'm getting a similar heating effect from the wire, of course, because it's producing current. Under load, under a 2.5 ohm load, neither of these coils produce any significant voltage drop. So the power factor remains pretty steady. But the bowl-shaped coil, in the presence of a moving magnet coming across the open face, or the closed face I should say, this being the open face, this being the closed face, produces much less drag effect on the moving magnetic field than does a standard pancake coil. And that's what I wanted to show you, and that's what I think is very significant. Coming up, I'm going to be winding more of these. Different configurations, conical shape, as well as dome shaped. If I can, multi-layer, dome shaped and conical shape as well. Those are going to be tricky coils. This was tricky enough, but that's the way it is. It takes patience to wind these. And there's my experiment. I hope you enjoyed it. So that's it. I hope you enjoyed watching this little experiment that I've conducted. I believe that the results that I have found and are demonstrating here right now are very, very significant. I would encourage others to try winding similar coils, perhaps even conical shape. I'm going to be experimenting with various geometries. Nikola Tesla, one of the things that he taught us was that the geometry of the coils that we wind is very significant. And based on what I have found, it looks as though this is beginning to approach what is called by most experimenters as a monopolar magnet. And everyone knows that if you can create a monopolar magnet, you have possibly a way to energize a wheel and create free energy. So, yeah, quite significant. So that's all for now from the lab, Zero Fossil Fuel. Please rate, comment, share, and subscribe to my videos. And as always, peace, everyone.